Hello, today's lesson is going to be on the pour-through technique for the measurement of pH and EC. Before we review the technique, let's take a moment to review what pH and EC actually measure, what they mean. If you recall from the lesson, pH is a measurement of the acidity or alkalinity of the soil, or really of the solution in the soil. What I mean by solution is liquid phase. In the soil, in this media here, we have airspace, pore space. That pore space at different times is filled with either water or air or a combination of both, right? So on the low side of the pH scale we have acid. On the high end of the pH scale we have alkaline or alkalinity or basic type of solution. The problem is once you start to deviate from the middle, from around 6.5 or so, if you go more on the acidic side, certain nutrients are going to become unavailable. On the flip side, if you go on the alkaline or basic side, now there's other nutrients that are going to become less available. If you're in that middle range at around 6.5, that's when the majority of your nutrients are readily available. Right, so that's pH. Now let's cover EC for a moment. EC stands for electroconductivity. EC is a measure of the salinity or the salts in solution. Remember, when I use that term salts, I'm referring to fertilizers in general, right? We tend to think of salt as sodium chloride, but really when we refer to salts in solution, we're talking about nitrogen, phosphorus, potassium, calcium, magnesium, etc., right? All the essential elements that we need to supply for the plant. So one way we do this, by using a meter like this one. This is a Growline Hanometer. It's a handheld meter that will measure both pH and EC. And if you look, on opposite ends of this device, we have two electrodes. A current is passed through those two electrodes, and the electroconductivity then is measured that way. So based on the amount of salts in solution, the higher the salt concentration, then the higher the EC value. So you've probably heard of other ways to measure salinity or fertilizers, salts in solution, and that's part per million. So when you hear part per million and or electroconductivity, just know, you should just realize that those are two different ways of measuring the same thing, right? And about the conversion factor works out that 1 EC is equal to about 660 or so part per million, all right? Now, let's go through the pour-through technique. So, here I have a freshly irrigated potted plant, right? So in this container, we have media. That's what we call this, soilless media. Here I have some distilled water. It's important to use distilled water because the pH is neutral and the EC or part per million value is 0 or very close to it. I take some distilled water, I pour it on top of the root ball, and what we're seeing here now is water pouring through the container, hence the name of the method, the pour-through method. And what's happening here is that distilled water isn't going through the container. It's pushing out the water that's already in that pore space through the container, right? So we're capturing what we call the leachate, or the soil solution. After we have enough leachate there in our catch pan, I will go ahead and collect the leachate sample. This is what it should look like, light brown tea type of color. We know there's some good organic matter in there, hopefully a good amount of salts as well, or enough for the plant to grow at least. I'm also going to take this container again and fill it up with some distilled water to make sure that we clean our instruments in between samples, or at least at the end of running all these samples. So I'll get my meter, here's the leachate. I swirl around the probe in this solution. I'm waiting for it to settle. It's now settling at around 7.2 pH, a little high, but still not too high that most of the nutrients should be available. Now hitting another button to measure EC, and we're getting an EC value of around 1.0. All right, so I'll go ahead and turn off this meter, take it out of solution, rinse it in distilled water, and then store it properly in storage solution. That way we make sure the electrode here is properly kept and will last a long time. The second meter I'm going to use is a combo by Hana, another Hanometer. Smaller, more compact. This one also measures pH and EC. Before I remove the cap, turn it on. Same technique to measure now. I'm trying to compare and contrast readings using different meters. I'll explain why here shortly. We're getting a pH of 7.2, so it's lining up nicely with the other meter. And an EC value of about 1.0, so again, we're matching up. You may be asking yourself, why have I used two different meters, right? Well, a couple of important things to go over here briefly. It's critical for growers, farmers to know where their pH and EC is at. This right here lets them know how their fertilizer is performing, what's available for the plant to take up, etc., right? However, if you're using a meter that's not calibrated and giving you inaccurate information, that is worse than no information. So think about that for a moment. No information is better than bad information. Why? If you're making decisions based on inaccurate data, you could lose your crop. You could over-fertilize, under-fertilize, etc. So regardless of the type of meter that you're using, you should always make sure that they're calibrated and providing accurate data. This concludes today's lesson. Hope you've enjoyed it. Thank you.